how does your brain differentiate homophenes in lip reading? Imagine trying to understand someone speaking silently just by watching their mouth move. It might seem simple, but your brain is doing a lot of complex work to tell similar-looking words apart. Homophenes are words that look alike on the lips but sound different. Think of words like pat and bat. They look very similar when spoken silently. So, how does your brain figure out which word is which? The answer lies in a fascinating process that combines visual cues, brain activity, and context. When you watch someone talk, your brain first processes the movement of their lips in the visual cortex. This area responds to how fast and how often the mouth moves, especially movements happening more than once per second. These visual signals are then sent to a part of the brain called the right angular gyrus. This region is like a translator that combines the visual info with what it knows about language. It looks at the slower changes in lip movements, below 1 cycle per second, to help predict what sounds might be coming next. Even though lip reading is silent, your brain doesn't just see mouth shapes. It also activates areas usually involved in hearing speech. This cross-activation means your brain is creating a rough idea of what the person might be saying, based on visual clues. This helps in telling homophenes apart because it links what you see with what you expect to hear. Higher up in the brain, areas like the left inferior frontal gyrus come into play. These regions help resolve confusion when words look alike but mean different things. They use clues from the sentence, your prior knowledge, and the situation to pick the right word. This process involves conflict resolution and inhibitory control, which helps suppress incorrect options and focus on the correct one. For people with hearing loss, these brain processes are especially important. Lip reading becomes a vital skill because it combines visual information with what the brain expects to hear. Improving lip reading involves training these neural pathways to better interpret mouth movements, use context effectively, and integrate visual and cognitive cues. In summary, your brain differentiates homophenes through a multi-layered process. It starts with visual processing of mouth movements, then integrates this with auditory expectations in the brain, and finally uses language and context to resolve ambiguities. This incredible neural teamwork allows you to understand speech even when hearing is limited. Remember, everyone's brain works a little differently, so practice and patience are key. If you're working on lip reading or communication strategies, consider consulting with professionals who can tailor techniques to your needs. Your brain's ability to adapt and combine these cues is what makes understanding speech possible, even in challenging situations.